Welcome to a new how-to guide prepared by the Urban Big Data Center. My name is Rafael Verduzco and I am a research associate at the University of Glasgow. Today, I will introduce a multimodal transport routing tutorial for the UK with R. This tutorial is split in two parts. The first part is an introduction to routing in the UK. The second one, which is presented in a different and separate video, is about travel time matrices. The present video consists of 5 sections. The first section is about the rationale, the second one is about the requirements to compute this type of estimates, the third is about preparing the inputs, the fourth is about the routing parameters, and the fifth is the detailed itineraries from one origin to one destination. Broadly speaking, there are two types of resources that can be used to estimate routes from one or several origins to one or several destinations. The first one is a local base. That one uses local resources that are used in a local machine. The second one is an API based. That one essentially is a tunnel that connects the user with a predefined network. Some examples of those are the ones used in Google Maps. Today, we will focus on local-based methods. The reason for that is because today there are several alternatives that are open source. That means that these alternatives increases transparency, they are free, and there are a large community of users that can provide support into the technical aspects of this. The second one is because these types of resources are fast and powerful. A recent comparative study found that the time consumed to estimate a large all-to-all travel time matrix take only 1/2 in R5R when compared to a second fastest alternative. The third reason we're using the local-based approach is because they are flexible. Essentially, they allow you to estimate different scenarios. For example, we can adapt the parameters to represent different types of residents or represent different times of the day. Also, we can introduce modifications to the road or pedestrian network. Additionally, we can estimate scenarios where there are changes in public transport infrastructure or operation. And finally, it is because of compatibility. This is because these type of resources take inputs that are organized in universal formats. Although these type of resources present several advantages, they also have some requirements both in terms of hardware and software. For this tutorial, we're going to use the example of Glasgow in Scotland. This is a medium-sized example. For this, I would recommend having 8 GB RAM memory and a 4-core processor. In terms of the software, we're going to require a Java Development Kit version 11. This specifically needs to be version 11. It can be an earlier version or a later version. Conveniently, we have included in our materials a step-by-step guide on how to install this software. The next software that we are going to be using is R and R Studio. This works through different packages or extensions. The ones that are used for this tutorial and the specific versions are listed below. Tidyverse is useful for manipulating the data and the outputs. OSM extract is useful to import some of the inputs that are going to be needed for this. R5R is the core piece of software that we are going to be using to estimate the roads. UK to GTFS package is useful to transform the data into the appropriate format. And finally, MapView, it is useful to visualize the results. Also, there are some data requirements. First, it is essential to have information about the road network and the pedestrian network for the area of study. For this tutorial, we're going to use OpenStreetMaps. Additionally, we will need information about the public transport itineraries. For the case of the UK, we will need to assemble this information from different resources. First, we will need information about heavy rail or regional rails. This information is made available openly by the Rail Delivery Group. We can access this information following the link provided in the slides. The first piece of information is the Rail Delivery Group. If we access the link which is provided in the slides, it will take us to the next view. This is the Rail Delivery Group platform. First, we will need to create a new account. After we have our username and password, we can access the platform. We have different options, but we will use the data download. Once we have accessed the data download, we have, again, different alternatives. The information that we will need is the timetable feed. We can simply click on download. The information which is provided when you access the data, it is the information which is valid at that time. Luckily, for this tutorial, we're providing the data that we will require, so it will be the same every time we run this tutorial. But for future references, this is how you can access the data for regional trains and heavy rail public transport services. For our estimates, we might want to include information about local public transport services, that is, bus or tram services. The Bus Open Data is a platform that assembles this information for different regions within the UK. If we access the link which is provided in the slides, that will take us to the next view. In this view, again, we will need to register an email and a password. Once we have accessed the platform, there are essentially two alternatives. The first one is to download the data in trans-exchange format. However, there is also the alternative to download the data in GTFS format or General Transport Feed Specification. This is actually the format that the software that we will be using for this tutorial recognizes. For this tutorial, we're going to use data for the region of Scotland. Again, if we access this platform and we download the data, the information will be valid for the date that we are accessing the information. For this tutorial, we have also included the information for local buses, which was valid at the time that we created this tutorial. As an alternative to Bus Open Data platform, TravelLine also offers similar information about local public transport services. However, note that this source of information provides the data in trans-exchange format, which means that we will need to transform into GTFS data, which is the format recognized by the software that we will use for this tutorial. It is time for you to put hands on. We have organized all the materials and resources necessary for this tutorial in a GitHub repository. You can access the repository by clicking on the link which is provided in the slides. Clicking on the link will take you directly to the GitHub repository. This contains all the materials necessary to follow the tutorial. You can download the contents by clicking on the code or green button, and then by clicking on download zip. The process might take a few seconds. Once the download is complete, you'll see that there is a zip file. You will need to extract all of the contents of this file. The folder contains all the materials necessary, but this is organized in an RStudio project. To access this, I would recommend clicking on the .rprod file. This is the RStudio project that we prepared for you. If we look under the Files tab, we'll see that we have different folders containing different pieces of information. If we look at the data, we'll see some information that we will need to follow this tutorial. One of these is, for example, the information that we access from the Rail delivery group. This information is also available in GTFS format. We transformed that information previously, but we also are including the code to show you how to do that. Additionally, this folder contains information about the road network, which we access from OpenStreetMaps. We will also include the code to show you how to download this information for your own area of study. There are some other pieces of information that we might need at different stages of the tutorial, so we will cover some of them at a later point. There is another folder which is the support. If you access this folder, you'll find a PDF file which contains a step-by-step guide on how to install the Java Development Kit version 11. The R folder contains the scripts that we are going to be using for this tutorial. They are organized in 4 sequential scripts from number 1 to number 4. If we click on the first script, you'll see the code that we used to download some of the data which is included in this repository. Essentially, this contains 2 sections. The first one is about how to download the road and pedestrian network from OpenStreetMaps, and the second one is to download the data from the Bus Open Data platform. However, you don't actually need to run this code because, as you just saw, we already download and transform this data for you. However, we are including the code for your reference if you want to download the data for your own case of study. If you notice, I did not include the code to download the data from the Rail delivery group. That information needs to be manually downloaded, as I just showed you, and then it needs to be transformed in the appropriate format. That's exactly what we're doing in the second script. This script essentially shows you how we actually took the information that we download from the Rail delivery group and we transform it into GTFS format. To do this, we conveniently use a very useful package to use this type of information in the UK, which is called UK to GTFS package. Additionally, I'm using the tidyverse package to manipulate the information in this script. Again, this script, you don't need to run it because as we previously saw in the data folder, we have the original data accessed from the Rail delivery group, and we already have it in the GTFS format. However, we're including the code to show you how to run this process, and eventually you can run it using your own data for your area of study. And the third and most important piece of information, it is the road network as we download it using the OSM extract package. With this information at hand, we will proceed to the next code, which is really what this is doing is setting the environment, and it also shows some examples to estimate some detailed itineraries from one origin to one destination. This time we will actually run this code. Before going into the details, I just wanted to mention that this script is separated into different sections. The first section, as I briefly mentioned, it builds or loads the network, including the different pieces of information that I just mentioned. And the second one focused on the estimates on the detailed itineraries for different modes, for example, pedestrian roads, cycling roads, and finally public transport roads. So if we come back at the top, the first thing that I will do is just double check that the required Java Development Kit version 11, it's actually running. So if I run this function, I'll get this result in the console, which is saying that I have the Java version 11.018. So with this, I confirm that I have the appropriate version to run the R5R package. The second thing that I'll do before loading any package is allocating the memory, the virtual memory that I want to use for this session. In my case, I think 4 gigabytes will be enough. Now I will proceed to load the R5R package, which is the main package that we will be using. In my next step, I will define a folder. If I come back to the root directory, we'll see that I only have the data directory. But I will create a new directory where I will store my network and the input data file. So I will call that directory Scotland router. Later, I will create the directory using this path. And we'll see we have this new directory, which is currently empty. But what I will do here is that I will bring the information about the public transport, both the rail and the local services, as well as the OpenStreetMap network here into this folder. And there we go. We just copied the files into the Scotland router folder. So now what we're going to do in the next step is that we're actually going to build the multimodal transport network. And to do that, we are going to use the setup_R5 function, which is part of the R5R package. The main argument that this function takes is the data path, which is exactly the same that I just defined, and it is the folder that contains the information that I want to include in the routes that I will be estimating. In my case, you will see that I have 2 different files containing the transport timetables for the different for the same region. This function will actually combine those 2 informations and the different services that are operating in the same zone. So I will just run this function, and it might take a few seconds or a few minutes depending on the capacity of the local machine. So it just finished creating the network. In the console, I got a message that says that finish building network.dat. And actually, we'll look at the files in our folder. We'll see that we have new files. The main one is the network.dat, which contains the information about the network, and it integrates the road and pedestrian network, but it also integrates the public transport timetables that we just included in the folder. I'll just clean the memory before proceeding, and now we will estimate the simple detailed itineraries from a single destination, from a single origin to a single destination. Only now I will load the rest of the packages that I will be using for this session, and this is just a practice to avoid any type of conflict with the R5R package. Now I will define the point of origin In my case, this is going to be Glasgow Central Station, and here I will define it as a simple data frame. The first column of the data frame is going to be a unique identifier, and then the next two columns are going to be the location by using the latitude and longitude of this location. In the second one is the point of destination. In this case is Mulgai, a location which is around 10 kilometers away from the Glasgow city center. And the fields and the type of the object is the same as the origin. We will start with the pedestrian roads. And for this, first we have to set a series of parameters which will allow us to customize the type of road that we want to create. Just note that this is the simplest type of route, since it is basically just using the information which is provided by the OpenStreetMaps network. Alternatively, or as additional information, we can also incorporate data about the topography of the area of study if we include .tif files. At this moment, we're not using such information. So as I said, it is basically using information from the network. The first thing that we need, of course, is to specify the mode as walk in capital letters, as we see it now. And we also can define the maximum trip duration. The default of the R5 R package is 120 minutes. So the longest journey that it could estimate is 2 hours. But in this case, I'll extend it to 4 hours. Another thing that we can customize is the walk speed. By default, this is 3.6 kilometers. So I will set it to 4.8 kilometers. This is an interesting feature since we can adapt the speed to represent different segments of the population or different types of travelers. Lastly, I will define the time and date of departure for this journey. For the case of the pedestrian roads, this is not very relevant since as I just mentioned it is only using the geometry of the network. However, we need to specify time and date of departure in the function. To estimate the detailed itinerary, very conveniently, I will use the detail_itinerary, which is part of the R5R package. And this essentially takes the arguments, the parameters that we just defined. So first of all, it is the network that we just created, the R5R_core, the origin, which is Glasgow Central Station, destinations, mode, time and date of departure, and maximum trip duration and walk speed. So I just simply run this function, it doesn't take nothing. And we can see the class of the output. One of the nice features of this package is that if we look at the class of the object, it also contains an SF element. That means that it also produced the geometry of the suggested route by the package. So we will visualize it in a minute. But before we proceed, I want you to see the information which is contained in the output. Since we're only estimating a single route, we only have one row in this output. We have information about the origin here. We also have information about the destination, time of departure, and most importantly, we have the estimated total duration. In this case, it takes about 140 minutes that is 2 hours and 20 minutes, to walk a distance which is about 11.1 kilometers. As I said, we can very easily visualize the geometry of the road using the map view function, and we will see that this produces or prints the suggested route. So in my case, the origin is the Glasgow Central Station, and this is the suggested route to reach the destination Multimodal. Next, I will move on to estimating bicycle routes, and the first thing that I will do here is switch the mode to specify bicycle, again with capital letters. And I will also modify the speed, which by default is 12 kilometers per hour, but in my case I will set it to 16.5. Another interesting feature which is included in the R5R package is that we can also account for the level of traffic stress of cyclists. That is, there is a scale that goes from 1 to 4, and 1 represents travelers with very high stress, and 4 represents travelers with very low stress. That means that travelers that are represented with high stress would prefer quiet streets or green spaces, whereas travelers who are represented with low traffic stress would prefer routes that are shorter or faster, and it doesn't matter if they are represented as being as heavy traffic roads. This feature is important because it allows us to, again, represent different segments of the population, or perhaps different profiles of the cyclists that we're trying to model. In my example, I will estimate 4 routes which correspond to each of the levels of stress. So for this reason, I will wrap the detail itineraries function within the lapply function in R. The arguments are similar as they were before. The only difference is that I am specifying the bike speed, and I'm also defining the level of stress with this dynamic argument. Again, I run the function. It is very fast for these 4 simple routes. And since the lapply function in R returns a list, I just want to bin the rows into a single data frame. Here I will just print the output that produced for each of the roads according to the stress level. So we will see that travelers represented with a low stress level, those are travelers represented with a high stress level. It will take them about 76 minutes to go from Glasgow city centre to Multimodal, while the cyclists that are represented with a low stress level, it will take them about 43 minutes. We can also see that the distance reduces as the stress level reduces. This is because the model route is represented or chooses a path that is shorter. It doesn't matter if it has heavy traffic. Again, the results contain the geometries of the routes, so we can very easily map those routes. And we'll see, for example, that there are different routes. So for the possibly more experienced cyclist, they would prefer a route which is similar to straight line, and possibly this is following main roads in Glasgow, while cyclists that are represented by high stress level would prefer a route that goes, for example, along green areas, or that are along this path alongside the river. So we see that this argument is very convenient, again, to represent different types of travelers. We will move on to public transport routes. And when it comes to public transport routing, R5R offers a variety of options and alternatives that could be considered within this type of modes. The first one, for example, is that it allows multimodal journeys that combine, for example, walking and transit, but it could be expanded to a combination of, for example, bicycle and transit. For this example, I'm going to set the mode to walk and transit, and please note that if we specify transit, that includes all of the public transport modes that are included in our information, but we can limit it to specific transport modes such as subway or bus or regional trains, among others. Another feature that we can customize in these public transport routes is the maximum access or egress walk time in minutes, and that refers to the very origin of the route to the first public transport station or stop, and the egress time refers to the walking time from the last public transport station to the final destination. So in this case, I'm going to set it to 15 minutes. So the arguments that the detailed itineraries takes for public transport for this example are very similar, except that I'm adding the maximum walking time. So I run this function, again, it is very fast for this example. And if I print the information, we'll see that it displays more rows as it did before. Actually, in this dataset, we have 3 rows, and each of the rows in these detailed itineraries refers to each of the legs of the multimodal journey. So for example, the first one, if we look at the mode, we'll see that this is a walking segment of the journey. The second one is by rail, and the third leg of the journey is by walking again. Again, it contains information from the origin and the destination, and importantly in this case is the time of departure that we are setting this route. It also includes the total duration of the trip, which in this case it adds up, including all of these legs of the journey, to 50 minutes, and the total distance is 12.8 kilometers. It also contains detailed information for each of the legs of the journey. So for example, the segment duration. So the first one corresponds to 14 minutes walking, then 22 minutes on board on rail, and lastly 5 minutes walking to the destination. Additionally, it contains information of the waiting time. So the first one, it is 0 minutes because it doesn't take time to start walking. Then once in the station, the traveler will need to wait 8.5 5 minutes, and then it reaches or they reach the destination. As before, it also contains the geometry, so we can print this public transport route, and this is the information that we can obtain. So as we saw, the first segment is a walking segment of the journey. Then this consists of a rail segment, and finally it reaches the destination. Since the time it takes to go from one place to destination by public transport can be different according to the operational characteristics of the public transport service, the R5R package introduces a concept which they term time window. In our example, we defined the time of departure at 8 in the morning, and here I am using a time window of 30 minutes. Which says that I will consider different alternatives departing at the random time between this time window from 8 in the morning to 8:30. So we can easily incorporate this argument using the time window argument within the detail itineraries function, and I run this function. And as you can see, this takes a little longer than the previous routes, and that is because it is trying to identify the different alternatives within this time window. So we print the result. We'll see that there is more information. First, there are 42 rows in this data set, which correspond to different alternative journeys. So, for example, we have option 1, 2, and 3, which are estimated to depart at 8:24, 8:24 again, or 8:07 in the morning. So also we can count the number of alternatives that are available during this window time. And we see that there are 11 different options for this time window. And we can also see the different travel times that are computed within that window. So it can, so those are the times of departure, sorry. So the times of departure which were calculated within this time window are from 8:07 in the morning till 8:29 in the morning. And here in the next line, we can see the travel time estimated for different for these different alternatives. So this can range, for example, the shortest travel time within that specified time window could be 38 minutes, while the longest it would take it is 52 minutes. We can also plot the geometries for these routes, and we can see the different alternatives. Some of them are combining walking and the use of rail, but most of them overlap, so we cannot clearly see all of the alternatives. So to conclude this part of the tutorial, I would like just to simply overlap all of the different modes that we just estimated. As I mentioned, a very nice feature of the package is that it includes directly the geometry of the estimated route. And we can see, for example, here what is the suggested route for bicycle according to different stress levels for pedestrians and for public transport users. I'll just clean my environment to continue with the next code for the next part of the tutorial. In this first part of the tutorial, we have covered the essentials for estimating multimodal transport routes for the UK, covering the data sources, the requirements both in terms of software and hardware, and also some data manipulations that we might need for the special case of the United Kingdom. And we have also set the network, which is a very important step in this method. Also, we run some examples using a variety of modes and adjusting the parameters which allow us to the ability to represent different segments of the population or different profiles of the travelers. Thank you very much for watching, and hopefully you can join us for the second part of the tutorial.